Alright, today's lesson's on completing the square. Alright, so what is completing the square? Well, the idea when we're completing the square is to write the left side of the equation as a perfect square, as you see that we've done here. And then from there we can solve directly for x using inverse operations. So for example, once we have a quadratic written in this form, the next step would be to take the square root of both sides, leaving just x minus 3 on the left-hand side of the equation, and plus or minus 5 on the right hand. Remember, when we take the square root, when we force the square root on something, we have the plus or minus of it, because negative 5 times negative 5 in this case is positive 25, and so is 5 times 5. Finally, we add 3 to both sides, and we get our two solutions by one time letting 5 be positive, so we get 5 plus 3 is 8. And the other time by letting 5 be negative, so negative 5 plus 3 is negative 2. The question is, how do we get that left side to be a perfect square? The answer is, well, once you get the quadratic written in this form where we have x squared plus bx equals c, such that there is no a term other than 1, then you take that middle term, you divide it by 2, and then you square it. And then you just add that to both sides of the equation. This will be a little more evident when we get into a few examples. But first, let's just practice identifying what number we would have to add to both sides of the equation to make it a perfect square. So take a moment to look at this example. We already have it such that there is no a term other than 1. And so we're going to take the b term, we're going to identify the b term. Alright, well we can see right here that the b term is 8. Simply after that we cut it in half, divide it by 2. So 8 divided by 2 is 4. We take that and we square it. So 4 times 4 is 16. Once you start doing a few of these, they become pretty easy. So we would add 16 to both sides if the question was, what number do I have to add to both sides of the equation to make it a perfect square? Now we can go ahead after we add the 16 to both sides, and like we did in this case, the next step would be to write that left side as a perfect square. So let's see what I mean by that. We want to write it in this form. So we have x plus the b over 2 squared. And remember that b over 2 squared is that middle term just cut in half. So remember our equation, we had x squared plus 8x plus 16. Well, the middle term here, the b term, is 8. So I'm going to cut that in half, and that's the number that goes inside the parentheses with x. So if I'm going to rewrite this as a perfect square, I'm just going to take half of 8, which is 4, and then write it as a perfect square, as we did in this bottom here. Let's try another one. So take a moment to pause the video and see if you can rewrite this trinomial as a perfect square. What would you have to add to both sides? Alright, so take the b term, which is negative 12, cut it in half. Alright, so that would be negative 6. Then we're going to take negative 6 and square it. So negative 6 times negative 6 is positive 36. And we would fill in the blank in this equation with 36. And then we could factor this, right, as g minus 6 squared. Remember, it's just what goes in the parentheses is half that middle term. And you guys have done factoring before in previous lessons, and you know that if I were to factor this, I'd be looking for a number that when I multiplied them came up to 36, and when I added or subtracted them came up to negative 12. Well, with a little bit of trial and error, you can see that that number is negative 6 times negative 6. It's negative 6 times negative 6 is 36, and negative 6 plus negative 6 is negative 12. Alright, so how does adding that b over 2 squared to both sides, how does that complete the square? Why do we even call it completing the square? What square are they talking about? Obviously, when you multiply something by its own self, that's called a square. So when we're writing a binomial, to a second power, it's a perfect square because we're multiplying it by its own self. But there's more to it than that. You can think of these quadratics as actually completing a square, hence the name. So I'm going to let you watch the short video on what it actually means.
So in math class, you're often told that if you have x squared plus b times x, that you can solve this kind of a quadratic by completing the square. And you're told to do that, take your b term, divide it by 2, and then square it. Now I remember that when I was in school, this really bothered me. It seems like a really arbitrary process. And I had no understanding of what was actually happening. I want to talk to you in this video about why does this actually represent a square? What's actually happening here? And I want to show you that because I think it'll help you understand why this is actually an awesome thing. And again, the goal here is that when you complete the square, you can factor something really easily. So if I had something like x squared plus 5, well, no, let's not use 5, 10x. If I said factor this by completing the square, what you would do is say, oh, well, b is equal to 10. And what I have to do, according to this formula, is add 10 divided by 2 squared. So 10 divided by 2 is 5, and 5 squared is 25. And then by writing in 25, we've completed the square, which means, of course, we can factor this really nicely by just writing x plus 5 and then squaring that. Because x plus 5 times x plus 5 will give you, right, x squared plus 10x plus 25. And that's just that's what's so nice about completing the square. You can take a quadratic and factor in something wonderful like this right here. But anyway, we're not looking at that in this video. We're talking about why does this actually make sense visually? And that's the important part. So let's say we have x squared. So this is my x square right there. And an x square, of course, is an x square because, well, the side lengths are x by x. Remember, if you multiply x by x, that's x squared. And you can think of that visually as an area. So we have a square, an x by x square. Now originally, right, before we complete the square, we're assuming that we start with something like this, which is the x square plus b times x. So what does that mean? Well, we know what x is. It's about this height right here, right? We have no idea what b is. It could be this long, it could be shorter than x, it could be anything. Let's assume it's around here. So basically what's happening is you have an x square plus bx. So bx is just b, this length, whatever it is, it could be anything, times x, which you already know is this height right here. The problem is this is not a square, right? We have this rectangular chunk plus this chunk over here, and maybe it'll work out to form a perfect square, maybe not. But most likely it won't be a perfect square. So the goal of completing the square is to take all this stuff and actually make a square. So how do we do that? Well, look what the formula says. It says add b divided by 2 squared. What does that mean? Well, that means I'm going to take a line, right? I'm going to cut this square into 2 pieces, right? I'm going to take b, cut it in half. So whatever this distance is, I'm dividing it by 2. So let me just go back and redo that. b divided by 2. We'll clear this off. So imagine this piece is here. We're cutting it in half. What's that going to look like? Well, now we'll get 2 pieces. Let me use a different color there. I don't want to switch on it too much. 2 pieces that are half of what we had before. And I'm separating them just so we can see it clearly. You could smash these together if you wanted to. Now the height is still x, right? We haven't changed that. What we did change was this width right here, right? This is now b over 2, and now this is b over 2. And we don't have a rectangle yet. We just divided this in half. And in fact, if we can rearrange these, right, we're going to notice an interesting thing. So let me actually clear this off again. We're going to rearrange these pieces. Okay. All right. So I'm going to rearrange those 2 pieces we just saw. Here we have b divided by 2 by x. And if we put the other piece here, look at the gap that's remaining. Well, again, this is b over 2, this distance. This is x, and this is x, so it fits perfectly with this square. And this distance over here is b over 2. If you look at this picture, you might notice that in order to form a perfect square, there's a piece missing. So we should add in this piece right here. And by adding in this piece, we would complete this square. We'd actually make a square. The question is, what is this little square? Well, look at it. This side right here matches this length. That's b divided by 2. And this side right here matches this length. That's also b divided by 2. So we actually call this little square b divided by 2 times, that's a b divided by 2. And that equals b divided by 2 squared. So let's go back to our formula. This is a picture of completing the square. X squared, that's this square right here, plus bx. Well, we started off with bx. Remember, there's a big rectangle over here. We basically said, let's cut that in two, right? It's the same area. We're just rearranging it. So this chunk right here and this, if we put them back together, we would get this part, bx. We haven't changed anything, just rearranged it. We're completing the square because we know that if we rearrange these three pieces, there's a gap over here that can complete the square if we add in an area that's b divided by 2 squared. So again, this is a visual representation of completing the square. You're actually completing a square. That's the goal. You're adding in this little piece over here. It's basically a b over 2 square. And by adding that, you'll always be able to get a perfect square, just like we did in this case right here. We took this quadratic, rewrote it, right? We added in b over 2 squared, and then we were able to factor it into a wonderful term like this. Because every square, if you think back to what you know about squares, if it's a perfect square, right, let's say I have a square with an area of 100, well then you know you can figure out the root or the side length by taking the square root of 100, which is 10, and you get a wonderful whole number answer. The same principle applies here, it's just that we're going to factor the quadratic by finding this wonderful term squared, and then later on we can take the square root of that. That's the basic idea. Alright, I hope that
All right, I love geom I love those geometrical explanations of an algebraic concept. All right, so let's talk about the quadratic formula and completing the square. All right, the quadratic formula is shown there that we all know and love was in fact derived from completing the square given the standard form of a quadratic here. All right, so although I encourage you to look at the steps, and I know they do it in your lesson, I'm not going to go over the steps here. Right? If you want to look up the steps, you can go to YouTube or some other math site, and you can see all the steps there. I think it's an academic exercise that's worthy of an Algebra 2 student, but the algebra gets a little bit too advanced, I think, for an Algebra 1 student. So instead of going and confusing you further with the steps I'm using to actually completing the square on this and getting the quadratic formula, I'm going to let you guys look at that, and you can always come to me in one-on-one chat if you really want to see how to do it. So let's go over the steps again for completing the square. All right. So the first thing we do is if we have the c term, the constant term, right, we move that to the other side of the equation by subtracting it or adding it if it's negative, right? So we get that constant term to the other side of the equation. Then we got to make sure that the a term is 1, right? So if it's not 1, like if we have a 2x squared or something like that, then we got to divide every term by whatever the a is, okay? Next, we figure out what our b term is, our middle term. We divide by 2, right? We cut it in half, we square it, and we add that to both sides of the equation. That's how we rewrite the left side as a perfect square, as you saw, and then we can solve directly for x. So let's do an example. Let's solve this equation by completing the square. All right, so my first step, I don't want this number, this constant term at the end. I want to push it to the other side. Okay? So I'm going to go ahead and subtract that from both sides of the equation. And I'm left with x squared plus 10x equals negative 9. I'm going to check to make sure my a term is 1. And in this case it is, right? A is 1. There's no other number in front of the x squared. Alright, so we see that b is 10. So I'm going to go ahead and take that, cut it in half. Well, half of 10 is 5. Then I'm going to square 5. So 5 times 5 is 25. And that's the key to completing the square. Once we do that and we have this 25 and we add it to both sides, like so, now you'll notice that the left-hand side is ready to be factored as a perfect square, right? So I'll go ahead and do that. And x squared plus 10x plus 25 does in fact factor as x plus 5 squared. Another time, if you're not sure what goes in the parentheses when you're squaring it, remember it's just half of the b term, right? So half of 10 is 5, and that goes inside the parentheses with the x. On the right-hand side, we got that negative 9 plus 25 is 16. And now finally, we're in this situation where we can solve directly for x. So we want to get x by itself. Well, I got to bust it out of these parentheses, which it's being squared. So to undo that, I need to take the square root of both sides. Right? That's the inverse operation of squaring is square root. So that leaves us with just x plus 5 on the left-hand side and plus or minus 4 on the right-hand side. So remember, when you take the square root of something on the other side of the equal sign, you always get the plus or minus of it. All right, and our last step to get x by itself would be just to subtract 5 from both sides of the equation. So we get that x is plus or minus 4 minus 5. So now we can get our two solutions. One time when we're letting x be positive on the left-hand side here. So I get that 4 minus 5 is negative 1. And another time when I let x, the 4 be negative. So negative 4 minus 5 is negative 9. So we get our two solutions of negative 1 and negative 9. I'm going to give you a moment to pause the slide and let you go ahead and try this one. All right, good. So our first step here is to go ahead and, if there's any constant term, to move it to the right-hand side. Well, there isn't. We already have something on the other side. Then we're checking to make sure that the a term, the term in front of the x squared, is 1. In this case, it's not, right? It's 2. So that means I got to go ahead and divide everything by the 2. So we're left with x squared minus 4x equals 5. Now we got to figure out what we need to add to both sides of the equation, right, to make the left-hand side a perfect square. And get used to taking it, that middle term, right, cutting it in half. So a half of negative 4 is negative 2. Then taking negative 2 and squaring it. So negative 2 times negative 2, again, is positive 4, which we add to both sides of the equation. Now we're ready to factor our left-hand side and simplify what we have on the right-hand side. So remember this, we just take that middle term and cut it in half. That's what goes in there in the parentheses. So we got x minus 2 squared equals 9. And now we're ready to solve for x. So we're going to take the square root of both sides. We're going to add 2 to both sides. And then we're going to get our two answers from 3 plus 2 is 5, and negative 3 plus 2 is negative 1. And so our answer is negative 1 and 5. If you have any questions, as always, you can email me, message me, or call me.